Okay, so that's the history of Sunpower. Now for the importance of efficiency. This is something that trips everybody up that gets into the field is, and you see one of the other things you're not supposed to write in your business plan when you write your business plan is efficiency doesn't matter, it's cost per watt that matters, okay? That immediately means to the reader, if they're a savvy reader, that you've never sold a solar module in your life, okay? But we saw it all of the time. This shows the value chain once again, going from polysilicon all the way through to the system. That's not, everyone knows that. What's more interesting is to lengthen all these according to how much cost is in each of these, okay? And that's this one. So now I have squeezed each or expanded to show how much actual cost is involved at each of these steps. Notice, for example, that all of the things up to making a complete solar cell, okay, refining polysilicon, growing an ingot, sawing it into a wafer, and making it into a solar cell is only about 40% of the total system cost, okay? This is an important number to keep in the back of your mind because let us suppose that somebody came to you and said, I have a way to make solar cells virtually free, okay, for you. But they're not quite as efficient. Well, how efficient would they have to be? 40%, so the system now costs 60% of what it did before because that 40% was just given free, right? And so let's suppose that it produced 60% as much power. What have you done? Nothing, all right? Unless you get confused and you sell giant amorphous silicon machines to make solar cells that are 5% efficient and aren't exactly free. So if somebody had come to you and said, I want to sell you $1 billion machine to deposit amorphous silicon thin film cells, they're going to be 5% efficient, but in the future we're going to be able to work them up to about 9. And you can put these into panels. You think you should buy it? I mean, it's that simple, right? So they don't, the companies that did that don't do that anymore. So this shows, for example, that notice that the actual cell manufacturing is 14%. Let's do another thought experiment. Suppose that we come up with a more complex cell that is twice as expensive to make. Okay, that 14 becomes 28. And the total becomes 114 instead of 100. Okay, suppose the cell is 20% more efficient. Have you won? Yeah, you clearly, right? If it's 50% more efficient, you've won a lot. Okay, so the value of messing with that 14% in improving performance is leveraged down, upstream and downstream incredibly, and it's a very powerful tool. This just shows, I'm running out of time, so I'm not going to talk about I'll do that more when we talk about solar cells. But this shows the type of cell that Sunpower started making with all the contacts on the back and the interdigitated N and P fingers on the back side of the cell versus a standard solar cell, which has an N-type collector on the front and a P-type collector on the back. And in fact, for an old line solar cell person, they would, and we were told numerous times that this cell here doesn't work. It can't work. The physics can't possibly make it work. But in fact, of course, it does work. But what we essentially have done is taken the N-type diffusion on the top, interdigitated it on the back, between the P-types, and just moved that to the back surface of the cell. It doesn't really matter where these junctions are. You can just sort of morph the current flows in the cell around quite dramatically as you move them around. There's nothing magic about it having to be this sort of one-dimensional structure going from bottom to top. This just shows the, this is something from a Sunpower ad. So it just shows the efficiency has been going up a lot. We recently just announced what called the X21 product, and I shouldn't say we anymore, it's a bad habit, but they announced a X21 product that's a 21% efficient module that uses 24% efficient cells in making it. This is a project that I think is indicative of what is really the state of the art in solar projects today. This is a project at the University of California, Davis, and it's a student area, a student residence area. Those are dorms mainly, and then you can see a pool, and there's some stores and stuff, some parking structures. There's PV all over this thing. In fact, there's 600 units here, and the whole thing is net zero energy. So PV supplies all of the energy. There is no natural gas brought on site. It's all of the heating is done by ground source heat pumps powered by PV. So this is an example, an existence proof, if you will, of a net zero energy village that is not consuming outside resources at all.
Using the grid for back.
Exactly.
The net is average over a year.
Exactly. Net average over a year. So the giant PG&E battery that's free for a while. Not forever. This just shows some of the data about it. But anyway, it's a cool project. If you're out that way, you should stop and see it.